All right, so yesterday we finished off the class with the question about the camper who went south, then went east, and then came back a little bit north. All right? We decided that because we were being asked to calculate their displacement, that a line representing their displacement would be drawn from their initial position to their final position. If we wanted to figure out how long that line was, and our numbers, okay, on here were, this was 1.2 kilometers, this was 0.8 kilometers, and this was 0.3 kilometers, okay? We figured out that what we had to do was figure out how far over, in this case east, did she go, and how far north or south did she go. Okay, or in other words, a horizontal or x component, okay, and a vertical or y component. Right? We do that by looking at all the parts of the trig. Okay, so what we said is she only went east in terms of east and west. There was no backtracking that way. So she ended up 1.2 kilometers east of where she started. So x equaled 1.2 kilometers. Okay, she went south initially, but came back a little bit north. So she went 0.8 kilometers south, 0.3 kilometers north, meaning that overall she ended up 0.5 kilometers south of where she started. Now that I know the components of my overall displacement, I can now calculate both the magnitude of my displacement, that's the length of the line, and the direction of that line. Okay? And that's what we're going to be doing today, but we're going to be doing it crazier. The lines are not all going to be straight along compass directions. Okay? They're going to be angled instead. Right? So it's going to involve a little bit more trigonometry. Right? So we got to, first off, learn how to resolve a vector into its components. Okay? And that's kind of what we did here. Actually, this is a little more complex than what we're going to do today, okay, in terms of resolving a vector. So resolving a vector into its components essentially means doing this. I'm given this vector. I'm told that it is, let's say, 100 meters long and angled at 30 degrees above the horizontal. Okay? If I follow that line, I go somewhat to the right and somewhat up. Agreed? Okay, those are my two components. The horizontal or over component and the vertical component or up. Okay? So y and x. Okay. Can I figure out what y and x are if I know the hypotenuse and the angle? I sure can. Okay? I just have to use this. Okay? If I want to find out how big x is adjacent to my 30-degree angle. Okay? It's beside it, touching it. Right? So if I want to find out what x is, and I know the hypotenuse, which one of these trig functions am I using? Sine, cos, or tan? Cos, okay? Because cos relates the adjacent side to the hypotenuse given the angle. All right? So if I wanted to find x, I would do this. I would say that the cos of 30 degrees, that's my angle, equals x, the adjacent side, divided by the hypotenuse. 100 meters. Okay. So if I want to figure out what x is, all I do is take the 100 and multiply it over to this side. Okay. That'll let me figure out what x is. Everybody with me so far on that? Okay. So if I did that, sorry, I should have started that before. It takes 30 seconds to start. Oh no. Okay, I'm just going to do it on my other calculator. Sorry, I don't know what's going on with that. Never 4. Okay, so if I just go cos of 30, okay, and multiply that by 100, right, I'm going to get 86.60, and I want to keep all my decimals in here. Okay, so 86.6, and that's going to be meters. Okay. That's going to be x. How would I calculate y? Okay, I could do Pythagorean Theorem, but it actually takes longer than the way I was thinking. Sine, yeah, okay. I'm looking for the opposite side. I've got the angle and the hypotenuse, right? So I would just do what I did here, except do it with sine, okay? The sine of 30 equals y over 100, so 100 times the sine of 30 would give me y. And sine of 30 is 0.5, so this is 100, or this is 50, sorry. 50 meters. Okay? Everybody with me on that? So now I've just figured out the components of that vector. I figured out how far it goes horizontally and how far it goes vertically, okay, when I follow that. Right? Now here's why that's going to be important. I could be given something like this. So the vector we just dealt with, added to that vector. Okay, so the question would say, add these vectors, 100 meters at 30 degrees north of east and 50 meters at 20 degrees south of east. Okay, so I draw a diagram. I draw the tail, the head, okay, and I put on their triangles. Okay. Each of these has an x component and a y component. We already calculated the ones for the red one. Okay, this would have an x component, this would have a y component as well. The question is basically looking for me to calculate the overall displacement of the object. So where would I draw a line that shows the overall displacement of this object? Right, actually the other way around, but yes, that's where the line's going to go. I'm going to connect my initial position with my final position, right? Because that's what displacement is, the change in position. Okay, so that line there represents my overall displacement. Okay, now, here's where it gets interesting. This line also has a y component and an x component. Okay. If I take the x component from my red triangle and add it to the x component from my black triangle, does that add up to blue x? It does. Okay. I have to figure out how far over do I go in total and how far up and down do I go in total by finding all the x and y components, which is what we just did a minute ago with the red triangle. We would do it again for the black triangle, find out what x is, find out what y is. And we put them together to figure out what our overall over and up or over and down is for that particular vector. Okay? So there's a bit of trig in getting all the numbers, but when it comes right down to it, all you're doing with those numbers is adding or subtracting them. Okay? So once I've got y and x for the blue triangle, can I do Pythagorean theorem to get the big line? Can I use trig to get the angle? Okay. We've already done that, right? We did that for a perpendicular vector yesterday. Okay. So these are all steps we already know how to do. There's just a lot of steps to put together into one question. Okay. That's where the difficulty in vector addition rises. There's nothing really hard about vector addition. They're just kind of long. Okay. There's lots of steps to do in a vector addition question. Okay. But it's always the same steps. All right, so we just talked about this, okay? Magnitude and direction for a vector component, or for a vector quantity, sorry. Okay, if we have vector A, it has an x component, how far over it goes, and a y component, how far up it goes. Okay, so those go along with an xy plot like you would have learned in math. Okay, this is the positive x-axis. Back this way would be the negative x-axis, positive y-axis, and negative y-axis. Everyone okay with that? Okay, and a compass rose works the same way. North would be positive, south would be negative, east would be positive, west would be negative. Okay. All right, so we can figure out all of these components using trigonometry because we would know how long A is and what direction it's going because it's a vector quantity. It would have magnitude and direction. Okay, that would allow us to figure out its two components. Right, and that's what we do here. Okay, we already did that on a previous example. If I wanted to find the x component, it's the adjacent side on this triangle. It's not always going to be the adjacent side, but it is on this triangle. Okay, so I would use cos to find it. Okay, if I want to find this side, it's the opposite side, so I would use sine. If the triangle was drawn the other way, okay, like that was terrible. Okay, and over. Okay, like that, okay, and I was given this angle. If I was finding y would be the adjacent side, so I'd use cos, and x would be the opposite side, so I would use sine. Okay, doesn't really matter as long as you don't memorize. Oh, x is always cos because it's not. Y is not always sine. It depends on how the triangle is drawn. All right, everybody okay with using trig to find the sides? All right, so if we do that, this is just the example here that they have. We already did one like this. Okay, so if my blue line there is 175 meters long and is 50 degrees above the x-axis, okay, finding the x and y's would result in us doing this. Okay, y is the opposite side, so I would go d, 175, okay, multiplied by the sine of 50 degrees, because that's my angle. That side would be 134 meters, right? And then for x, if I wanted to find it's the adjacent side, so I would take the hypotenuse, multiply by the cos of 50, and it would be 112 meters long, and now I would know my two sides. Okay? Then I could use that along with the next triangle, okay, if I was doing a vector addition question. Okay, questions so far? Right. This is also what I kind of diagrammed for you before. If I'm adding two different vectors, okay, together, this is essentially what I'm doing. Here's vector A, okay, it has an x component, ax, and a y component, ay, okay, and I'm adding it to vector B, which also has an x component and a y component, okay. The overall, what we call resultant, is C, the red line, okay. If I take ax and bx and add them together, like you see in this diagram here, that would be the x component for C. Okay? If I take ay and by and add them together, that's going to give me the y component for C. Okay? Now I would have both sides for C, do a Pythagorean Theorem operation, do a trig calculation, I'll have magnitude and direction. Right? So it's always the same steps. Draw the diagram, tail to head, okay? Find all the x's and y's using trigonometry, okay? Add the x's together, add the y's together to get your final triangle. Pythagorean theorem, trig calculation to get the angle, final answer. Okay? Always the same steps when you're doing vector addition. Okay, and we already talked about that. All right, I want you guys to write this one down. Diagram's already drawn for you. Okay, but I want you to write this one down and draw the diagram. I'll give you a minute to do that, and then we're going to walk through the whole thing together. Okay, as your first example of a vector addition question. I just changed the color because I don't have yellow. I want to have my colors match when I do this. Okay, so here's what we're going to do with this question. Right? So we've got our diagram drawn already. Okay, that's step one. Now I need to find all the x and y components, okay? Because I'm going to follow vector A first, and then I'm going to follow vector B. So I'm going to kind of go up and over, and then I'm going to come down and over, and I'm going to end up where C points. This is going to be my final position over here, okay? This is my initial position here. So that means that vector C also has a right angle triangle that looks like that. That would be kind of a completion to that diagram. Okay, so our first step is that we need to calculate how far up, okay, that's the y component of A, okay, and how far over the x component of A, okay, we go when we follow vector A. Right, so we're finding the x and y components of the first vector. Okay, so essentially blue x, okay, blue x is, well, they've drawn the angle in here. Right? They drew the triangle over here. That's not what I would do. Okay? I would generally try to draw my triangle in where the angle would be, right? But they didn't do that. So what's this angle here? 20, right? Okay, so I'm going to use that 20, not the 70. I could use the 70, but then I have to draw my triangle over this way. And then it makes the diagram get really overlappy. Okay, I know that's not a word, but that's kind of what happens. So, okay? All right, so x is the opposite side to the 20-degree angle. So what trig function am I going to use to find it if I know that A is 145 meters long? Sine, it's the opposite side. Okay, so x is going to be the sine of 20 degrees times 145 meters times the hypotenuse. Okay, here's how I got that. I know that in trig, the sine of theta equals opposite over hypotenuse. I was looking for the opposite side, so I simply multiplied the hypotenuse over. Okay, that's where that manipulation comes from. So my calculator will start this time. Kinda need it. So we're going to go sine of 20 times 145, and since my calculator is not working on it here, sine of 20 times 145. Okay, so we got 49.59, and I have to keep all my decimals. This is what's going to be really cumbersome this way. Okay, meters, and that's going to be to the right. Okay, because it just says, it doesn't give me compass directions here, it's saying above the horizontal. Okay, so that'll just be a positive number because it's along the positive x-axis. Okay, now I need to calculate what y is. Okay, what trig function do I use to get y? Cos, yeah, it's the adjacent side. So I'm going to use the cos of 20 times 145. Same manipulation, except cos is adjacent over hypotenuse, so I just multiplied the hypotenuse over. Okay, so blue y, cos of 20, okay, times 145 is going to give me 136.25543 meters, and that's also positive because it's up. Oh, is there a reason you're running a whole decimal? I am, significant digits. Okay. With significant digits, I keep all of my decimals until the very end of the question. Okay, that's why I tried to start the calculator 4 times, because I can just go back and grab the numbers on that calculator. I can't do that on this one. Okay, so I've got to write them all down. Right. All right. So now I've found all the components of the blue triangle. Now I've got to do that for the green triangle. Okay? Find all the x's, find all the y's. All right, so I want to find green x. Green x is adjacent to my 35-degree angle, so what trig function am I going to use to find it? Cos. Okay? So x, green x, will be the cos of 35 times 105 meters. Okay, so that's 86.01096.465 meters, and that's also positive because it's going to the right. Okay, now I need to find green y. Green y is opposite the 35-degree angle, so I will use sine to get it. Okay, so we'll go sine of 35 degrees times 105 meters. Okay. 35 is going to give me 60.22552582. Okay, meters. Is that positive or negative? Negative. It's downwards. Okay, and that's important for me to remember later. All right, I've got all the x's and all the y's now. Can I figure out what my resultant, that's C, its x and y are? Okay, so next step is add the x's together to get your resultants x, add your y's together to get your resultants y. All right, so here's how that looks. Okay, red x is going to be 49.59, okay, or blue x, okay, plus green x, which is 86.01. Obviously, I'm going to use all the decimals when I add these together, I'm just not writing them all again. Okay? All right, so red x is going to be 49.59 plus 86.01096.465. Okay, so red x is 135.6038854. Okay, again, keep all the decimals until the end. It makes a difference when you're in Pythagorean Theorem and you're squaring that number. Okay, if you've rounded it off, it makes a difference when you calculate your final answer, and when you get your final significant digits, you might get it wrong because of that. Okay, so keep all of the decimals. All right. Red y, or cy, is going to be the sum of green y and blue y. But one of them's positive, one of them's negative. Okay, and that's fine. So I'm going to take blue y, 136.25543, okay, and I'm going to add to that negative 60.2255, whatever. Okay. Could I just subtract it? It'd be fine if you did that. But because it's called vector component addition, I always add the negative. It's up to you. You can subtract. You guys are smart enough to figure that out, unlike me who has to add the negative instead. Okay. So we're going to have our 136.25543 plus negative 60.22552582. All right, so our overall y, red y here, is going to be 76.02990418 meters. Okay, that's positive and that's positive. Right? They're up and over to the right. Okay. I now know the two parts of my resultant or overall displacements triangle. What do I do with them now? What's my next step? Yeah, I can find C, right? I'm looking for this. I need the magnitude of my overall displacement, and I now know what this side and this side are, so I use Pythagorean Theorem to get my overall displacement, or C in this case. So that'll be the square root of 135 with all the decimals squared, okay, plus 76 with all the decimals squared. Okay, so C's magnitude will be Okay, 155.4636937 meters. All right, so I've got that. Now I know how far I go, what my displacement's magnitude is. But displacement is a vector quantity, so I still need its direction. And how do I get that? Yeah, you can use trig, and you can use any trig function you want. At this point, you calculated all the sides. If you made a mistake, it's too late now. Okay, you can use sine, cos, or tan. Okay, whatever one you want to use to get that final angle. I always use tan because it's my favorite, because I'm a nerd and I have a favorite trig function. Okay, so theta will be tan to the -1 of the opposite side, which is 76 with all the decimals, divided by 135 with all the decimals. Make sure your calculator's in degree mode when you do this one. Okay, so 76.02990418 divided by 135.60388. All right, so we're getting an angle here of 29.28 degrees. Which direction is that? Question gave us just positives and negatives and talked about the x-axis and the y-axis. This is above the positive x-axis. Okay? That's the only direction we can give because that's the only one we were given. Okay? See how they got the positive here? That's positive x, positive y. This angle is measured from the positive x-axis, so this would simply be 29.28 degrees above the positive x. All right. Before I write in my final answer, I need to look at my significant digits. Okay? How many significant digits should my answer have here? 3. Every single number I was given has 3 significant figures. I used all of those numbers. Okay? So my final answer has 3 significant figures. That means that C equals 155 meters at 29.3 degrees above the positive x-axis. Okay, I could have also said it's 155 meters at the complementary angle. That would be 60.7 degrees left, or sorry, not left, right of the positive y-axis. Either one of those directions would be fine. Okay, because they're the same thing. Okay, is it a lot of steps? And it took us quite a while because I went slow. Okay, but if we once we get good at this, and it just takes repetition, these go very quickly. All right. On an exam, I wouldn't give you one that had 2 angled vectors like this. Okay, every year on your unit exam, the one that you get is like 1 horizontal and 1 at an angle, or 1 angled and then a horizontal or a vertical or something like that. So. Okay, you don't have to do all the trig calculations for 2 vectors, just for 1. Ready with me there? So the steps, okay, always the same. Draw the diagram, identify x's and y's, calculate them, okay? Add the x's together, add the y's together. Pythagorean Theorem, trig, done. Okay, 6 steps every time. Always the same 6. All right, questions on what we did there? All right. What part of this do people screw up most often? Not the decimals. The diagram. That's the part that people mess up. When they're drawing the vectors tail to head, they either don't draw their scale accurately, okay, they make a line too long or an angle too big or too small. They do all the math, and then the math tells them a number that doesn't agree with their diagram. Okay? On this one, there really wasn't a way to screw that up because A, you already had the diagram drawn for you, and the numbers were pretty clear, okay, as to where it would end up. But if you get one where you've got a couple of vectors, and maybe they do this, if you're just drawing that diagram, and you've been given the numbers, it's possible that you might make this line a bit too long and have it go past where it started, and instead of getting a resultant that's supposed to be east of north, you get one that's west of north. Okay? So you do all the math, you get a number that says east of north, but you look at your diagram and it's pointing west of north, and you go, I must have screwed up the diagram, right? No, you don't. You go, I must have screwed up the math. My diagram can't possibly be wrong, and then you put in the wrong answer because you just don't believe, okay, that your math could be right, when it's usually the thing that is right. Okay? It's usually the diagram that gets messed up. So a one like that is where scale is important. All right, so this is just all the written version of what we already did. So we're just going to skip through that because we already did it. Okay, and all right, so this is one where it's just finding the components. Okay, you'll notice this one's in kilometers per hour. Does that change what we do? If I want to find the x and y components of that line, doesn't change a thing. All it changes is that x is going to be in kilometers per hour and y is going to be in kilometers per hour instead of meters. Okay, but everything else is still the same. Okay, x is still the adjacent side. I'd use cos. Y is still the opposite side. I'd use sine. Okay. All right. I want you guys to try 1 and 2. This is just vector components. Okay, so just finding an x or finding a y. Okay, simple stuff, not the whole thing all together yet. All right, I'll make it a little bit bigger. Okay, don't do number 2 though, because it's using the rectangular coordinate system, which we don't use. So again, what's the hardest part of doing a question like this? Drawing the diagram. Okay, so in drawing the diagram, here's kind of what you want to do. Okay, so they're telling us first off that it's 15 kilometers, and then they're saying it's 40 degrees east of north. So when I want to draw this vector, I know that my reference is north because it says it's 40 degrees east of north. So the first thing I do is I draw a dotted line straight north to act as my reference. And then I go 40 degrees east of that. Okay, now I have a 15-kilometer long vector that's 40 degrees east of north. Okay, everybody follow me there? Okay, is that what giving everybody trouble? Give the diagram. Okay. So if you're ever stuck on that, okay, first thing you do is just draw a compass. Okay, and then, all right, if it's saying east of north, I put my pen on north. I go east of north. Boom, there's my triangle. Okay, wherever the angle arc is, that's where my triangle encloses. That's how I do it. Some people do like a hand thing and they point, okay, so it's north and it's east of north, or it's west and it's south of west if you're double jointed. Okay, and so on. But I often see people on the final exam, they're like trying to hide it. There's nothing to be ashamed of. Whatever way is going to help you get the triangle, okay, you do it. Okay? Some people are kinesthetic lenses, and some people are visual, it's fine. Okay? All right, so now that I've got that, they want to know what's the north component. Okay, well, this is the line I drew that was pointing north, so that's the one I've got to find. It is adjacent to the 40-degree angle, so I'm going to use the cos of 40 times 15 to get that one. Okay, when I go cos of 40 times 15, I'm going to get 11 kilometers north. Okay. Everybody all right with that one? Okay. Same idea with number 3. Okay, number 3, you've got a snowmobile that travels 65 kilometers, 37 degrees east of south. So I draw a reference line that's south because that's the direction that's the reference direction. Okay, it's 37 degrees east of that. So put my pen on that. I go 37 degrees east of that. Okay, that would be my east component. That'll be my south component. That's 65 kilometers. That's 37 degrees. Now I've got my triangle. Now I can solve for how far east it goes. Okay, is that side opposite or adjacent to the angle? Opposite, so what trig function am I using? Sine. Okay, so sine of 37 degrees times 65 kilometers, the hypotenuse, okay, is going to give me 39 kilometers east. Okay, like I said, the trickiest part is drawing the diagram. sure. Okay. Questions there? That's got rectangular coordinates. All right, I want you guys to do number 2 for right now. Actually, no, do number 3 first. Number 3 is a little bit easier, okay? I'm gonna give you a couple of minutes, and then I'll draw the diagram. See if you guys got the diagram right, okay? Compare it to mine. Okay, so do number 3 first, and see how you do. Okay. Oh, I was recording all that dead time. Okay, so for number 3, we want to draw the diagram here. Scale is important on this diagram. Okay, it's very easy to mess this diagram up, do all the math right, and then have that second guessing the diagram, okay, second guessing the math kind of situation going on. So our first part of this is 300 meters south. So that's just a vertical line. Okay, 300 meters due south. That's my first vector. Okay, does it even have an x component? If I go due south, do I go east or west? Now, I don't even have to do any trig with that line, do I? Okay, see, this is a simpler problem because you don't have as much stuff to do with it. You don't have to find an x and a y for this. Y is 300 and x is 0. Right? Now, our next vector goes on the head of the first, okay, and heads off North of east. So I'm going to draw a reference line, east, okay? And it's 75 degrees north of east. Is that a lot? Like, it's closer to vertical than horizontal for sure. And it's 500 meters long. So is it longer than the 300? Is it going to get past where the 300 started? Probably. Okay, I would bet on it anyway. Okay, this is where scale is important. All right, so hopefully I gave myself enough room. I don't think I did. I have to move everything down so it'll fit. Okay, so I'm going to go 75 degrees north of east. Probably could be even longer than that. Okay, but it's 550. Okay, so I don't need all of that line over there. Okay. My x component goes east, my y component goes north, okay, and this angle here is 75 degrees north of east. Okay, so now I've drawn the two vectors. Where do I draw my resultant or my overall displacement? Always from my initial position to my final position. Now you can draw this triangle either way. You could draw it across like this. I just don't like to have them cross my own lines if I can avoid it. Okay, or whatever makes more sense to you. So this will be my overall displacement. This will be its overall x, its overall y, and this will be the vector. Okay, that's what your diagram for question number 3 should look like. Okay, give you a few more minutes to see if you can get the rest of it here before I do the rest. All right, so we've got to find all the x's and y's now that we've got the diagram drawn. Okay, black x for the 300 meter vector there is 0 because it doesn't go horizontally. Black y is 300 meters south because it goes due south. Okay, so that one's quick and easy. Okay, the next one, the red triangle. Okay, we've got to find red x. Red is adjacent to the 75 degree angle, so we're going to go cos of 75 times 550 meters. What do you suppose the chances of that? Okay, so I'm going to have to enter it manually again here. So cos of 75 times 550 is 142.35. So 142.3504748 meters, and that is east. Okay, and then we got to find the y component, which is the opposite side. So sine of 75 times 550 is 531.2592045 meters north. Okay, so now that I've got those, now I can find my resultants, x and y components. Okay, so the x component's really easy. The only time I go east is here on red x. So red x and blue x should be they should be the same, they're equal. Okay, so that's easy enough. So red, our blue x then is just going to be the 531. Okay, with all the decimals. I'm just not going to write them there because I don't have room. Okay, and then for the y, 142. Sorry, 142, not 531. You are absolutely right. And now I've obliterated my diagram. Okay. Okay, so 142 we said, right? Yeah, okay. And then y is going to be the 531 minus the 300. That'll give us what's left north, right? Because we went 300 south, we went 531 north. Okay, so that should give us, okay, so we're going to have about 231, right? As our y component here. With obviously all the decimals, I'll use them in my calculation in a minute. All right, now I've got x and y. You see how much faster one of these is? Right? There's way less trigonometry to do because I didn't have to do any finding x and y for the black one. Okay, I don't have to add a whole bunch of stuff together because it's simpler. All right, so now that I've got that, now I can find what my overall displacement is, or at least its magnitude, using Pythagorean theorem. So that'll be x squared, 142 squared, plus 231 squared. Okay, so I'm going to have 142.3504748 squared plus 231.2592045 squared. All right, so my overall resultant here, okay, or D, is going to be 271.5593 meters. All right, so that's the magnitude. I still need to know the angle, right? The way I drew this triangle, my x component, the 142, is opposite, and my y is adjacent, so I'm going to find it using tan. So theta will be tan to the minus 1 of the opposite side, which was 142, divided by the adjacent side, which was 231. Okay, so second tan of 142.3504748 divided by 231.2592045. All right, that gives me 31.61 degrees. Okay, how many significant figures does my answer going to have here? 2. Okay, the 75 degrees only has 2 significant digits. I used it to do some calculating, therefore my final answer can only have 2 significant figures. Okay, so I'm going to be looking at a final answer here of 2.7. They did this wrong here. Okay, 2.7 times 10 to the 2 meters. At, I'm going to have 32 degrees, okay, and that is going to be for me east of north. Okay, is their answer okay? They've got 58 degrees north of east. Is that okay? Yeah. Yes, it is. That's a complementary angle to mine. It just means that they like drawing their triangle across the lines that they've already drawn. And I hate doing that. If you want to do that, you go right ahead. It'll still get you the right answer. I just find the diagram gets really busy if I end up crossing lines over. All right. How are we feeling about that one? Okay. Try number 2. Okay. Haven't done that one yet. Try number 2. I'll give you a few minutes, then I'll draw the diagram. Okay. And I'll get all that other stuff off of there. All right, so we've got one vector that's going to go 15 meters at 15 degrees north of east. Okay, so I'm going to draw myself a reference line that is due east, and I'm going to go 15 degrees north of that. Okay, so it's a pretty shallow triangle because 15 degrees is not a very big angle. Okay, there's x, there's y, okay, and it's 15 meters long. Okay, then from there, I've got a vector that's 13 meters long that's 5 degrees west of north. So I'm going to draw my reference line north. I'm going to go 5 degrees, so it's an even skinnier triangle and really crooked. Okay, so 5 degrees, here's y, here's x, and this is 13 meters long. All right, that means that my resultants goes here. So that'll be my overall displacement. This will be its vector, x and y. Okay, so your diagram should look something like that. All right. give you a few more minutes to get the rest of it figured out. Okay, let's have a look at this one here. So if we want to find our overall resultants, okay, our next step after drawing the diagram is to find all the x's and all the y's. Okay, so finding black x, okay, so the x for our first one here, right, it's going to be the adjacent side to the 15-degree angle. So we're going to go cos of 15 degrees times 15 meters. That's going to be 14.48888.739 meters, and that is east. Okay, and then when we want to find y is the opposite side, so it'll be the sine of 15 degrees times 15 meters. So we're looking at 3.882285677 meters north. All right, everybody okay with the first one? If we're looking for the sides of the green triangle, okay, similar method here, right? We're going to find x. X on that triangle is opposite, so we're going to go the sine of 5 degrees times 13 meters. And that's 1.133024656 meters, and that's west. Okay, and guys, you'll notice whenever I do this, I always write the compass directions beside my numbers. Why do I do that?
So you know which is positive and negative.
Exactly, so I know which ones are going to be positive and which ones are negative when I'm adding together to get my result.
Can I as well?
Yes. Okay, and then y is the adjacent side in the green triangle, so cos of 5 degrees times 13 is 12.95053108 meters, and that is north. Okay, so now that I've got those, now I can find blue x and blue y. Right? So blue x is going to be black x plus green x, but green x is west and black x is east. So I'm actually going to have to make the west one negative. So I'm going to have the 14.4, okay, plus negative 1.13. Okay, I'm going to put all the decimals in my calculator here, but I'm just not going to write them all down. All right, so we're going to have 14.4888. 739 minus 1.13302.656. Okay, so our overall y here is going to be 13.35586273 meters east. Right? Got to do the same thing with the y, but they both go north, so I can just add the two y's together. So that's going to be 3.88228567 plus 12.95053108. Okay, so we're looking at a y component here of 16.83 281.676 meters, and that's north. All right, so now that I know the two sides, can I find D? How do I find D? Pythagorean Theorem, exactly. Okay, so D is going to be our 13 squared plus 16 squared, so x squared plus y squared. 13.3273 squared plus answer squared. All right, so we're looking at 21.4877 meters, and that is, well, we don't know the direction of that yet. Okay, we just know that's the magnitude, right? And then we have to find theta, right? The way I drew the triangle, x is opposite and y is adjacent. Okay, so I'm going to go tan of x over y, or tan to the minus 1, sorry, of x over y. So that's going to be tan to the minus 1 of 13.3 over 16.8. Okay, obviously with all the decimals in there. So second is 10 of 13.355.6.273 divided by 16.83281676 gives us 38.4299 degrees, and for me that's east of north. That's the way I drew the triangle. All right, how many significant digits can my answer have? 1. 5 degrees measured to 1 significant digit. I would never do that to you on a test. It is just dumb to have an answer that has 1 significant digit. Okay, but that's what we got here, right? So we would have to say that this is going to be 2 times 10 to the 1 meters at 4 times 10 to the, sorry, not 10 to the 2, 10 to the 1. Okay, and sorry, 4 times 10 to the 1 degrees. And for me, that's east of north. Again, they do a weird thing with their significant digits, and it's not the same as ours. One of the other reasons we don't use the textbook. In addition to the fact that when we first got them, they were full of mistakes, and we sent them an email saying, this textbook is full of mistakes. They're like, oh, that's okay, just buy our corrections book. No. We just sent it back. That's dumb. Talk to your editor. All right, everybody okay with that one? All right, we're going to leave it there for today. Okay, you will have a quiz tomorrow, right? It will not involve that. Okay, we'll work on that a little bit before I quiz you on it. Your quiz tomorrow will be simple scalar vector B equals B over T kind of stuff. Okay, I will post that before the end of the day today. All right, if I can get everybody to mask up, I'll come around and spray your desk.